So everybody, my name's Steve Mills. For those of you who haven't gotten a chance to meet me yet, I am the co-project lead for Rack and Power project inside of the Open Compute. So I'm also a technical lead at Facebook. So I've been there about 6.5 years right now. I'll introduce Caleb here real quick. You can introduce yourself again.
One more time, right?
Sure, exactly. For those that haven't met yet.
Caleb Lusk, Rittal, 17.5 years, mechanical engineer, also a co-lead with Steve on Rack and Power Group. So
the purpose of this presentation is we're going to go kind of an introduction into the new advanced cooling solutions sub-project that we created earlier this year. So back in our spring summit in the U.S., I, as well as Bill Carter, the CTO of Open Compute, heard from many users. You know, what are we doing with liquid cooling? Why don't we have liquid cooling? How am I going to do liquid cooling? So after hearing that, just as a theme from the last summit, we decided to start working on setting up a sub-project related to that. So this is the announcement back in July, where we announced the creation of this sub-project, which runs underneath Rack and Power. So what I'm going to do is I'm going to kind of go through the kind of the history of where we've been so far the last couple of months. Kind of get people that are maybe not as familiar with what's going on, kind of involved in the process. So we just saw 2 presentations from participants that are already engaged in this process, and we're looking to get more people kind of involved. So the first thing we did is we sat down and developed kind of the scoping document that would describe the type of work that we're doing. This is a kind of I guess the thesis statement, I guess, in the scoping document. But really, the purpose of the project is to focus on the standardization of and definition of critical interfaces, operating parameters, and environmental conditions to enable non-proprietary, multi-vendor supply chain of liquid-cooled solutions. So that's really the core thing, right? Is we need to be able to deploy these at larger scales than where the current industry currently exists. So some of the key words that are up there, right, is we can start with, like, say, non-proprietary, right? So the focus of the project is similar to what we've done on other projects, right? If you look at, say, OpenRack, for instance, we have servers, Intel, AMD. They have a certain form factor for the motherboards. They fit into chassis. The chassis fit into OpenRack. The whole thing fits together. We've got power shelves from different vendors that you can get that provide power into bus bars. So it doesn't matter. They're all agnostic to each other because the interfaces between all those are defined. But I'm willing to bet that there's plenty of proprietary information inside the Intel or AMD processors, right? That's not part of it, right? It's defining the interfaces between those and the servers so they work together. We also have on the power shelves, there's plenty of proprietary information inside the PSUs. So that's not a problem at all, right? But they are interoperable, right? You can take one power shelf out and put another one in, and everything works together. So it's okay to have some proprietary stuff, but we want to be able to make sure that there's nothing in the system that prevents us from switching over from one system to another system. So if we've got, say, a particular proprietary, somebody that's got something that's proprietary and very interesting, that's great, right? We just need to be able to use that, for in this particular case, right? Right, we need to be able to plug that into the data center infrastructure and pull out that system maybe 5 years later and plug in a new system and have the data center interoperable with this solution, right? So That's kind of the theory behind the goal for this. And we definitely want multi-vendor supply bases, right? Because the scale that we're working at, we're not going to be able to have any one supplier be able to provide all the rest of the industry, all the users, from one vendor, right? We have to be able to interoperate between those suppliers. So kind of the next step of the operation was to kind of look at break down the type of work that we want to do into different work streams. So we came up with these four. There's architecture harmonization, which is kind of the overarching set. So it's kind of focused mainly on consistency across the other three work streams. Materials, compatibility, mainly the interfaces between the data center and the solutions. So this is kind of the overarching group to make sure that all of the information that comes out from the other work streams are all compatible with each other. We don't have any inconsistencies. So the cold plate. So this is mainly focused on direct contact style cooling. So these would be manual and blind mate connectors, fluid specifications. I've got secondary loop operational parameters. We're going to change that nomenclature after yesterday's meeting. And then we've also got the immersion stream, which is focused, like Rolf was saying, like very heavily on IT form factors, the materials that are specific to some of the fluids. Make sure you've got material compatibility and power distribution. And then we've also got another stream that's set up around the door heat exchangers. So these can be both active or passive solutions. Could be on the front of the rack, could be on the back of the rack. The kind of the volumetric of the doors, as well as flow rates and that type of thing. So this is just a real rough overview of the type of areas that are getting focused on each of these work streams. So there's much more detail out on the website where we've broken all these down. So you can definitely go and check those out. So these are the leads. So each of these work streams has a lead that's been assigned to them. So Austin Shellnut from Dell. There's Rolf Brink, who just spoke, and then we also have Jacob Na, who's right over here. Jacob, wave to everybody. So these are the different leads, right? You can contact them directly if you want to get help getting integrated and involved in this process. You can also get in touch with me, and we can get you aligned, whether you're a producer or a consumer of the gear, to get you involved in some of the processes that we go through and write these specifications. So if you want to take it on yourself to get involved directly, right, join the mailing list. That's the best way to get involved. The mailing list is where we will be pushing out the agendas for the meetings, when we're meeting, how to get involved, meeting minutes, as well as work product gets generated, right, that'll be posted, and you'll know that there's new stuff out there to go take a look at, so that you can review it before the next call. So that's the primary method of getting involved, and then all the materials that the group generates would be posted on the wiki. So we've only had a couple of months so far, so that's essentially we had our first extended working session yesterday. For 2.5 hours, we were able to make some progress towards defining exactly what the next steps are going to be. So as we go forward, we're looking for involvement from the community to kind of drive some of this through. So at this point, right, I can just, if you've got questions relating to the group or any of these streams or how to get involved or anything else, right, I can take questions now on that. Yes. Thank you, Caleb.
My question is about the scope of the project, so advanced cooling solution. Because this morning, when I attended the presentation about the facility,
Uh-huh.
the cooling solution which has been shown over there are slightly different from these three. So my question is whether there is the plan to expand the cooling solution, integrating also what the facilities, the data center facility, are currently using, like in raw coolers or evaporative cooling.
Sure. So the goal right now is not to necessarily extend this beyond like the row level. So we'll define the interfaces between, say, the facility cooling loop and these technologies, but we're not planning on going above above that level right now and actually defining the data center level. If we can define the operating parameters of these systems, for example, like the flow rate, the maximum temperature, these types of things for the facility loop, then at that point the facility is free to go and use whatever technology is best for them at the time. Each data center is going to have, based on their geography, is going to have perhaps a different solution. So if we can just define what these need from the facility, then that gives the facility plenty of opportunity to do whatever they need that's flexible for them. So we do plan on, as we develop some of these interfaces between the advanced cooling solutions and the data center, we'll of course be reviewing all those specifications with the data center's project of OCP to make sure there's an interlock between what we're expecting and what they'll be able to deliver, right? Because we don't want to be disconnected from that. And there's also a lot of other ASHRAE and other organizations that kind of help with that as well. So we're going to try and leverage as much from other sources, whether it's Liquid Cooling Alliance or ASHRAE or these other groups that are already developing stuff. There's no reason for us to recreate it, right? We just need to reference it rather than making up something special.
Yeah, I just have just one question, just to rephrase on what we were talking on yesterday's workshop. I mean, can we just let know to the public on what power densities we are talking on, what we are aiming for? I mean, I heard yesterday it was like 150 kilowatts per one rack.
Yeah, I mean, right now it's not going to be one particular data point, right? Because there will be consumers of this gear that are going to be sitting across the entire spectrum of power densities, and it's also going to make a big difference whether you're doing a door heat exchanger versus an immersion, right? They'll probably be working at a little different levels. So in terms of levels, power levels, so we do, as part of the Rack and Power project, we are trying to develop some preferred power SKUs for the rack. So we started this, we saw one presentation at the Spring Summit, so we started before that. So the goal of that was to kind of harmonize the power levels so that manufacturers that are producing power shelves, bus bars, PDUs, BBUs, they can all kind of have certain targets to hit, right? Rather than having to kind of guess, right? If we tell them, okay, 25 kilowatts is a 13 kilowatts, 25 kilowatts, 40 and 60 kilowatts are, those are kind of the target wattages. For the users of the gear, then that helps all those manufacturers target those power levels. If you've got IT gear that needs 60 kilowatts, but you can't get a bus bar that supports that, then you can't deploy, right? You have to have all those components all available, all at the same power capability. So those are more targets. Now, since we've started this particular project, right now we've got a cooling system that also kind of needs to link into that as well, right? If you have to be able to cool a 60 kilowatt solution as well. So ideally, right, we would like to be able to get some engagement with on the user side through HPC or some of the server group to kind of see if we can come up with some configuration levels that for rack level solutions that we could then kind of identify these power tiers, if you will, to kind of help everybody focus on certain power levels rather than just kind of everybody guessing on where they think it ought to go.
I would actually argue that the immersion or that the advanced cooling streams are mostly I would argue that the advanced cooling streams are mostly focused on interoperability, to make sure that whatever OCP stands for will be it will be possible to apply it regardless of whether it's immersed or direct to chip cooled or in a rear dock cooled rack. That you can inter-exchange components and produced equipment.
Yep, that's actually absolutely true, right? We're really more focused heavily on, particularly right now, on interoperability. So. Yeah, sure. Well, they want to hear it on the recording.
Okay. I just wanted to ask you guys to just make sure. I don't know who was driving the discussion with Octave, but since Octave Klava and OVH has the greatest experience from the industry in terms of the industrialized liquid cooling, since he offered the help to just share his knowledge, it would be great to just have at least some input on the, if not working team, if not working persons on the team, then just having their input, right, OVH input, because that's, I think those guys are. Yesterday we were asking about some emerging technology, whether you tried something, and the response was yes, we tried it like 12 years ago. So they have huge experience on that. It would be wise to use that, right?
Yeah.
Since he offered help.
Yep.
So with any kind of liquid cooling or anything, there could be leakage or things like that. You have to have sensors and things. So what is the effort to incorporate the manageability and firmware portion of this monitoring sensors?
So that is definitely part of the scope of work. So we plan to use the OCP defined management protocols. So then it's just a matter of defining what sensors are required. So we talked about that yesterday. We'll make sure that the current redfish profiles incorporate advanced cooling, the breadth of advanced cooling categories. We already put some stuff in there for door heat exchanger components, but I don't recall if we had enough categories to cover everything. So we'll definitely go and check in again with them to make sure that the profile that they're writing will incorporate all three of these streams. As for defining the minimum required whether it's safety or leakage, I don't know if we'll go that far because that might be very customer specific, or I mean, there's probably some best practices related to that we were talking about publishing. So we have the methodology to push up all the information all the telemetry and alarm information up. So then it's just a matter of, do we feel that we need to define the minimum requirements, or is that something that
maybe just establishing some thresholds and then allowing the user or the customer to sort of
I mean, we want to specify absolutely as minimal amount as possible, right? So here's your protocol for how you talk, and then that gives the customers and gear creators the opportunity to decide what they want to talk about. So I think that would be my first approach, unless there's some best practices that I haven't seen yet, where you definitely need to have these four pieces of information, no matter what it is. You know, we could certainly follow that. Yeah.
Mark Brand from Supply Design. We design high efficiency power supplies. So one of the things about power is it goes across so many industries.
Mm-hmm.
So
Yes.
my question is, do you have to be a member to be contributing to these discussions, or are there?
Yes.
Yes.
Yes, you'd have to be a member to contribute. So, and I can talk to you about that, or anybody else that's interested in that, on how to do that. It's relatively painless to go do. So you can join the mailing list and see what's going on, but yeah, if you want to contribute and participate, yeah, you need to join up. And we've had quite a few people join up in the last couple of months. So it's particularly associated with this particular sub-project. So it's a great time to get involved as things are kicking off. Anything else? Okay. Rolf, did you want to ask some questions to get a conversation started, or did you get enough feedback from earlier?
Actually, across the event, we got quite a bit of feedback indeed.
Okay.
But
It's up to you. We have a few minutes left, so.
well, actually, yes, I do have a question, and that's more. I mean, you work with Facebook, right? So
Yes, I do.
yeah, obvious. What does it take for Facebook before how much liquid does Facebook already incorporate in the white space? And what does it take for Facebook to adopt liquid to the scale that OCP is trying to support it?
Sure. So right now, if you look at all the stuff that we've got published, all the racks that we've got are 12 kilowatt max. So that's the only thing we've ever published. That. So in terms of adopting liquid, I don't really know if I could answer that right now. I mean, we're very flexible about whatever solution we need to go solve a problem, but right now, even like the AI stuff that we just announced, still from in the spring, is still fits in that 12 kilowatt envelope.
So what's what will it take for Facebook to really start considering liquid? I mean, replace Facebook with any hyperscaler, of course.
Sure.
Right? But I'm very interested in, because that's obviously also a driver to join these type of work streams.
Yep.
To help the hyperscalers consider these type of advanced cooling technology. So do you have any insight on what the requirements are before Facebook really starts considering and taking immersion or rear door or direct-to-chip serious?
Sure. The best I can tell you is that we see the same trends you see, right, where the power on the chip's increasing. So as that continues to increase, obviously air becomes a little bit more difficult to solve those problems with. So at some point, we'll definitely have to take a look at this, just like everybody else will. If we start exceeding, more than X number of kilowatts per rack, we're gonna have the same problem everybody else does. But I can't tell you when or if that would happen, though.
So are there actually companies in the room that are currently considering adopting liquid technologies? Not all at the same time, please. No. Anyone want to respond to what it would take before you can actually start considering liquid? I don't know.
Maybe you would, maybe you do. I can try. I used to work for a big color company, and we also have customers that runs APC systems, and they run 50 kilowatt steady load per 19-inch air-cooled. Works fine. So the need for it will be there, but it's not here today. We can run 50 kilowatts in air-cooled rack without any problems.
So are there any other arguments against adopting liquid in that sense? What was the recognition from OCP towards adopting these work streams? And I mean, I'm very much in favor of that. I do see the movement of the industry. So what is the? Is there actually a pull on liquid technologies from the hyperscaler level, which is the driving force behind OCP?
Sure. All I can tell you is that there's quite a few customers that were asking me to find out what was going to go on. You know, why aren't we not doing this? So I can't speak to their individual needs or interest. Right, none of that was shared with me. There's just a lot of interest in getting this going because the.
But is it simply driven by density or energy per rack? Because you can do 50 kilowatts in a rack.
Sure.
Right? So it's that simple. Or is there also a sustainability angle, or is there a different agenda behind it? Is there anything in particular?
Yeah, I don't know. Yeah, I don't know what was really driving them. Right? They just wanted to know why it wasn't already finished. Obviously, there's some demand there, but no, I don't know what was driving it.
So I would argue efficiency, probably mostly.
Sure. I mean, you would think that as your power goes up, that air would be more and more, or a better way to say, would be less and less efficient at cooling the same power level, as opposed to liquid. But there's also a lot of overhead as well to deploying a liquid solution into an existing air-cooled facility. So you have to get to some level of complexity before you choose to switch. Yep. Got more question out here. There you go.
Thank you.
Sure.
I come from Denmark, where more hyperscale are settling at the moment. But in terms of liquid cooling, I can see the potential in having liquid in data centers in general, in terms of having higher temperature outputs from the data center in the event of energy reuse.
Sure.
So that's for me a big advantage if you can go direct chip or immerse to have a higher temperature set return to a distribution of some sort.
Yeah, absolutely. Right, you get to recapture all that energy. Yeah. Definitely. Okay, no problem. Thanks. All right. Any other questions from anybody? All right. In that case, thanks everybody. I appreciate it.